the world's first successful practical use of optical fiber cable. The world's first superconductive cable with maximum voltage of 275 kilovolts. #1 share worldwide in car lithium-ion battery materials, in worldwide variable wavelength laser modules, and in worldwide steering roll connectors. In our proud 130-year history, we've had a long succession of world firsts. That's the power of Furukawa Electric Group. For over a century, materials have been the strength of Furukawa Electric Company Limited. One of our first areas of operation was in electrical wire. From there, we leaped forward to achieve the world's first practical application of optical fiber cable, firmly supporting the new IT society, and the push to deliver fiber to the X with leading-edge technology. Another material that was an early success was refined copper. From copper, we branched into other metals, such as aluminum and lead, contributing to the advancement and miniaturization of electronics. From our engagement in wire insulation, we developed polymers now used in a wide range of products, from industrial to household applications. From these three core materials, Furukawa Electric has developed a steady stream of innovative products for a wide range of applications. Let's take a look at some of the many products where Furukawa Electric's expertise in materials is put to use. Faster, greater. Telecommunications demand ever greater speed and capacity. With one of the top shares in the world's optical fiber market, Furukawa Electric is a leading company in this field, supporting the growth of super-fast, high-capacity communications worldwide. Optical fiber cable, optical systems, optical components, optical devices. Furukawa Electric's advanced technology is particularly applied in digital coherent systems, which are vital for expanding the capacity of optical communication systems. Digital coherent systems exploit the wave properties of light to vastly multiply the information-carrying capacity of optical networks. These systems use phases of light and polarized waves to increase the number of channels for transmission. But as distance increases, waveforms become dispersed. The receivers of these damaged optical signals must apply local oscillation light to read their original information. One key technology for this purpose is ITLA, which applies local oscillation light to recover damaged signals. Our micro ITLA is a smaller profile, lower power consuming laser source that enables optical devices to deliver high performance. As the demand for electrical power grows relentlessly, so does the need for stable, efficient power transmission. In 2013, Furukawa Electric succeeded in connecting a generating station with wind turbines floating at sea, a world first. This wind power facility floating in the waters off Fukushima Prefecture is part of a national project to spur recovery in that earthquake-stricken region. The turbines are connected to land-based facilities by special high-voltage riser cables we developed. Lashed by waves and tides, these cables must be extremely durable and water-resistant. We developed a system of intermittent buoys that make the cables trace an S shape in the water, generating just the right slackness to enable the cables to follow the motion of waves and tides, thus applying our expertise in behavior analytics. With the growing adoption of electric and hybrid vehicles, car electronics are advancing dramatically. The steering wheels of these vehicles sport an increasing array of buttons as they take on a growing range of functions. Our advanced technology is applied to control the development of airbags and the operation of numerous switches. Furukawa Electric's compact, lightweight steering wheel connectors are highly praised for their reliability and quiet operation, which have made them #1 in global market share. Today's vehicles are framed in wire harnesses, which connect various electrical systems like the nerve pathways of the human body. By switching from copper to aluminum, we have made wire harnesses lighter, contributing to improved fuel efficiency. Our HV rectangular magnet wires are applied in the motors of electric and hybrid vehicles. By changing the cross-section profile of wires from round to rectangular, we have improved the magnet wire space factor, thereby enhancing efficiency and saving space. Beyond these technologies, battery detection using original Furukawa electric sensors, heat analysis technology based on heat sinks, and world-beating alloy technologies such as anaerobic copper make Furukawa Electric a vital supporter of car electronics, from production to sales. Periphery monitoring radar supports advanced drive assist systems. Our expertise in telecommunications technology is driving new advances in communication-based steering systems. We also contribute to the increasing eco-friendliness of today's vehicles. Leveraging an array of technologies, from materials to production, Furukawa Electric contributes to the advancement and miniaturization of electronics. Heat dissipation and cooling are essential for today's increasingly sophisticated electronic products. Our technology is put to use in numerous everyday scenes, from smartphones and office LED lighting to vehicles and railways. Consider, for example, large LED floodlights used in stadiums. When LEDs exceed a certain temperature, their working life shortens dramatically. Our heat pipes are used to counteract this heat. Also used in satellites, these heat pipes are simple in structure and require no electrical power. As a result, they deliver conductivity some 200 times that of copper. This is a microcellular formed polyethylene terephthalate sheet, or MCPET. At first glance, it's a white plate, like an ordinary reflector. But MCPET is constructed of millions of tiny air bubbles just a few microns across. These bubbles repeatedly scatter the reflection for outstanding reflective performance. Its lightweight and ease of processing make it ideal for applications such as indirect lighting and vehicle lighting. Since its foundation, Furukawa Electric has especially prized research and development capabilities, which enable it to continually generate innovation. Each of our 7 research facilities pursues R&D in next-generation projects, each focusing on its own area of specialization. The Advanced R&D Technology Laboratory develops next-generation materials, researches advanced technologies, and creates new business projects. The technologies developed here range from nanotechnology and medical applications to ultra-lightweight, highly conductive materials. At the Laboratory for Fusion of Core Technologies, R&D activities create new value by fusing metal, polymer, and photonics material technologies with high-frequency electronics technologies. The Automotive Products and Electronics Laboratory develops the world-leading electrical wiring parts, weight lightening parts, heat-related parts, and other components such as the steering roll connectors, aluminum wire harnesses, and power and heat management technologies that support next-generation automotive and electronics markets. The Telecommunications and Energy Laboratory develops power transmission technologies and communication control technologies, optical fiber components and devices, and next-generation energy infrastructure. R&D is ongoing here in the fields of high-speed, high-capacity communication technology and micro-ITLA. For over half a century, Furukawa Electric has conducted R&D on superconductivity. In 2012, US-based Superpower Incorporated, a leader in the field of high-temperature superconductivity, joined the Furukawa Electric Group. Based on an array of core technologies, Superpower develops and manufactures leading-edge, high-temperature superconductive materials in partnership with Telecommunications and Energy Laboratory. OFS Laboratories, imbued with the DNA of Bell Laboratories, pursues fundamental research in optical communications and its applied fields. It is a wellspring of trends in an array of markets, covering not only communications, but also medicine, aviation, industrial automation, and geophysics. Furukawa Electric Institute of Technology Limited, or FETI, is a think tank in Hungary with members from Budapest University of Technology and Economics and others working on computer simulations, system development, and other operations focusing on materials, devices, and manufacturing processes. FETI especially contributes to our R&D efforts with advanced simulation analyses. Bound to innovate. Leveraging over a century of development in materials technology, the Furukawa Electric Group is pressing forward with relentless technological innovation, its gaze fixed resolutely on the future. Driving the worldwide development of diversity in energy infrastructure, smart communication infrastructure, and eco-friendly automotive technology, Furukawa Electric continues to contribute to society in its unique capacity as a developer of a wide range of materials.